Okay, so here we go. We start with the pure Bertrand model. Earlier I did the Stackelberg model, the Sweezy model, Kuhn model. Now we move on to pure Bertrand model, starting with assumptions. Assumptions are simple. Two firms which can obviously observe each other. Firms compete with each other through simultaneous price setting. So simultaneous price setting. And the earlier one, the Kurno one, which was simultaneous quantity setting, and no, in Kurno it was simultaneous price setting, and in Stackelberg it was simultaneous quantity setting. In Pure Burton, again we have simultaneous price setting. Homogeneous commodities. Till now we have homogeneous commodities in all the models. Then we have demand curve as Q is equals to A minus BP. This is market demand curve. Marginal cost is C, which is constant, and no fixed cost. So these are the assumptions of pure Bertrand model. In case of pure Bertrand model, firms reach equilibrium when both of them charges a price equal to MC. So both will reach equilibrium when they charge MC, which is marginal cost producing that good. This will happen because there is no possibility in the market which can make the firms trust each other. So there is no possibility of trust. So there is no trust within the firms against each other, even if they decide to collude. So this is important. Even if they collude, there won't be any trust. The other would think that the another one. So let's say A would think that B would undercut him on the price, and B would think A would undercut him on price as soon as they enter the market and will try to capture the market. So equilibrium is when both of them charges the marginal cost C. Even if they collude, there is no trust within each other. So I have given an example. If the firm collude and decide that both of them will charge monopoly price, then the collusion will not hold because both of them have fear of the other firm will charge slightly lesser and capture the entire market. They deduce their best response using backward induction. So their best response function is deduced through backward induction by continuously reducing their willingness to charge, and the only feasible solution is when both of the firms charges P equals to MC. This is the only feasible solution. This is also called Bertrand paradox. Why is it called paradox? Because even though there are only two firms in the market, they have the possibility to collude each other, charge the monopoly price, but they still are not able to get that extra supernormal profit. What I am doing, paradox. This paradox is that there are only two firms which can charge monopoly price and earn higher profit, but they reach equilibrium by charging competitive price and making normal profit. It is paradoxical that in spite of having market power of a duopoly, the firm charge like perfect competition and earn normal profit. If firms do not have equal MC, then the solution has two possibilities, assuming okay. So if their MC is not equal, MC1 is not equal to MC2. Then let's assume C1 is less than C2. Now we have two possibilities. If firm 1 has enough capacity, two possibilities. One is F1 has enough capacity, then uh, it will charge a price slightly less than C2 and acquire monopoly power in the market. Charge slightly less and become the monopoly in the market. Firm 2 will be ruled out. If the firm does not possess enough capacity, then it will accommodate firm 2 by charging C2. In this case, the firm 1 will make supernormal profit, but firm 2 will make normal profit. So the second possibility is that if the firm 1 does not have enough capacity, then it will accommodate firm 2 by charging C2. So it will charge C2 in that case. In this case, firm 1 will make supernormal profit, but firm 2 will make normal profit. Now we are moving to Bertrand model with product differentiation. So till now the products were homogeneous in the assumption, but now we move on to what if there is product differentiation. So Bertrand model with product differentiation. So the assumptions are two firms, simultaneous price setting, cost is assumed to be zero, so there is no cost to produce goods. Firm pays a market demand curve. So the market demand curve in this case is Qi equals to Ai minus Pi plus Pj upon 2. So I and j are firm 1 and 2. Ai is the attribute of the ith firm, maybe product differentiation since they are close substitutes. So we can write it as for firm 1 it will be A1, Q1 equals to A1 minus P1 plus P2 upon 2. For firm 2 it will be A2 minus P2 plus P1 upon 2. Pi has a negative coefficient to establish that their own price relation is inverse. So this is negative to establish inverse relation. Pj has a coefficient, positive coefficient, because commodities I and j are substitutes of each other. Positive because I and j are close substitutes. Now we move on to the mathematical part of it. So now the profit is obviously the total revenue is total profit since total cost is zero. Since total cost is zero, total profit is equals to total revenue. So pi 1 is equals to A1 minus P1 plus P2 upon 2 multiplied by P1. You can write it as pi 1 equals to A1 P1 minus P1 square plus P1 P2 upon 2. Now to maximize the profit, del pi 1 upon del P1, P1 minus 2 P1 plus P2 upon 2 is equals to 0. We need to get in terms of P1. So 2P1 is equals to A1 plus P2 upon 2. P1 is equals to A1 upon 2. Does it look like okay, A1 upon 2 plus P2 upon 4? So this is the best response function of firm 1 in terms of Bertrand model under product differentiation. So best response function of firm 1. Now we move on to firm 2, which is similarly P2 into Q2, which is total revenue, which is total profit. P2 is A2 minus P2 plus P1 on 2 multiplied by Q2. Am I doing it right? Sorry, multiply by P2. Just so that everyone is on the same page. This is Q2, this is P2. It will be now simply the same thing. A2 P2 minus P2 square plus P1 P2 upon 2. This is the profit of firm 2. Now del pi 2 upon del P2, which is A2 minus 2 P2 plus P1 upon 2 equals to 0. Now we move on to that A2. Am I doing it right? A2 plus P1 by 2 is equals to 2P2. P2 is A2 upon 2 plus P1 upon 4. This is the best response function of firm 2. Now the conjectural variation, which will be that if firm 1 increases price by rupee 1, let's say, then firm 2 will also increase its price by 1 by 4 given their best response function. So if you check out the best response function, both are dependent upon the other one's price. But if the firm 1 increases price by rupee 1, then firm 2 will also increase price even though if they didn't do anything in their product differentiation, like it is as it is like the previous one, they would still be increasing their price by 1 by 4. I have a diagram also which I don't think is necessary in this case, but let me just draw it for the sake. It is P1, here is P2, This is P2 and this is P1. Best response function is this. Best response function is, and at this point, so at this point it is actually a1 upon 2 and 0 on the y-axis, and here's 0 on the x-axis, so a2 upon 2, the maximum quantity produced. This point and this point, these are the equilibrium prices for both of them. Now putting the best response function of firm 2, this one, this one, into best response function of firm 1. It is simple. If you look at both of them, we have to just change the value of P2 as A2 upon 2 plus P1 upon 4 in here. So let us try it. So putting best response function of F2 in F1. So it will be like P1 is equals to A1 upon 2, right? Plus 1 by 4, and with A2 upon 2 plus P1 upon 4. It was like this. Then we go on to say A1 upon 2 plus A2 upon 8 plus P1 upon 16. Then we want it in terms of P1, so we will get P1 minus P1 upon 16 is equals to A1 upon 2 plus A2 upon 8. It will be 15 P1 upon 16. Here it will be like uh same thing, A1 upon 2 plus A2 upon 8. And then we will do simply that P1 star is nothing but 16 upon 15 A1 upon 2 plus A2 upon 8. Now we will cut these, so it will be 8 by 15 A1 plus 2 by 15 A2. This is the perfect response function, best response function of form 1. Now doing the same thing for form 2, we will get same thing, like putting in this equation, we just put the best response function of form 1, P1, in here, and we'll get similar thing, which will be, so you just change the variables, 8 upon 15 A2 plus 2 by, okay, I didn't write A2, let me just write it separately, 2 by 15 A2, 2 by 15 A1. There we go. These are the prices. And unlike in quantity where we used to add to get the total quantity produced in the particular market, we don't add it because these are the prices. And the best response function of firm 1 shows that the firm will increase its price with increase in its own attribute with a large coefficient. I think I should. So P1 star like this. So looking at this one, if form 1 increases its attribute A1, then it will increase its price by larger coefficient 8 by 15. But even if its computation increases its attribute, it will still be able to increase by 2 by 15. It's not much, but it's still, it will be able to. The final equilibrium also shows that increase in attribute of competitor allows the firm to increase its own price by a coefficient of 2 by 15. This is because any improvement in quality of even the competitor changes valuation of the commodity in consumer's basket. Consumer can see the average increase in attribute, which allows even the other firm whose quality has not improved to increase its price. In case of differentiated Bertrand, the firms will compete with each other by not only setting the price, but they can also compete with each other by even choosing their attributes. However, in a standard model, choice of attribute is kept constant. So in standard model, we don't have like different kind of qualities, attributes in the products, but in differentiated one, we obviously use it. That's why. Now, next we'll move to Burton model with price leadership.